Hi guys, okay, welcome to our first video that reviews the stuff we need to know for precalculus that we should already know, but may have possibly forgotten. So the first thing we're going to review are some linear functions. Let's start really back at the beginning with slope. Remember the variable that we use to represent slope is m, lowercase. One way to represent that is delta y over delta x. That's the change in y over the change in x. Or y2 minus y1 over x2 minus x1. That's the y value from one point minus the y value from the other point over the x value from the same point you used first on the top minus the x value from the same point that you used second on the top. It doesn't matter which order you put them in as long as you are consistent with the x's and the y's. Another way you might remember this is rise over run right. So slope is the rise over the run. So here we have a graph and we're going to find the slope of this line here. Now there's several ways we can do this. The first way is to simply count. Okay, remember that the slope is the rise over run right. Now if you look at the 2 points when we start, and we always work just like we read from left to right, we work from left to right. And we start at this point on the left. Now, we're not really rising, we're going down, but we're going down 1, 2, 3, 4. Now, since we're rising down, we say that's a negative 4 over, now how far to the right do we run? 1, 2, 3, 4, 5 spaces. So our slope is negative 4/5. Okay, now there is another way we can do this. Another way we can do this is to identify points and use the formula. So if I look at this graph, this point up here is the point 0, 3, and this point over here is the point 5, negative 1. That means that this is my x1 and my y1. This is my x2 and my y2. So if I use my slope formula, y2 minus y1 over x2 minus x1, I would have negative 1 minus the y value from the other point is 3 over, now I'm going to go back to the point where I got the negative 1 and my x value is 5 minus, go to the other point, my x value is 0. So again, I have negative 4 over 5. Ta-da! Now there is yet a third way, and I'm not sure you all know this way. And this is where we use our TI-Nspire calculator. So I'm going to take a minute here. I'm going to flip over to my calculator, and then I'll come back to the sheet. Ready? Get your calculators. Okay, guys. So here we are on the TI-Nspire. What I want you to do is open a graph page. So we're going to go to Menu. We're going to open a graph page. I'm going to escape out of that. Now, you may have a hard time figuring out where you are. So one thing you can do is on the menu, your View, Grid, Lines Grid. Now you'll see the graph paper. And I don't know if all of you are aware of that, but putting that grid on makes things sometimes a lot easier to do, especially if you're copying from the calculator to paper. So let's do this plotting points again. We're going to go to Menu. We're going to go to Geometry, Points and Lines, and the first thing we're going to do is we're just going to plot a point. So the first point we had was the point 0, 1, 2, 3, and I'm going to click Enter or the center click button. So you can either click here where the hand is, or you can just hit Enter. That's up to you. Notice also that as long as this symbol is in the upper left-hand corner, all I can do is plot points, which is okay because we also had another point at 1, 2, 3, 4, 5, negative 1, and I'm going to click Enter to drop it. Now I want to stop drawing points, but this symbol is still here. So we're going to hit Escape until that symbol goes away. Now I can do something else. Now if you want to check these coordinates, because sometimes it's not at exactly where you want, you point at it. Now I'm on a computer, so I'm going to right click. You want to hit Control Menu. Okay, so it's Control and then Menu. And you're going to hit Coordinates and Equations, and it's going to show you the coordinates of that line. And I'm just going to grab it and move it out of my way. I'm going to do the same thing over here at the other point. I'm pointing at it, so it says the word point, control menu, coordinates and equations. And I'm going to move it out of the way a little bit. So there we go. We've plotted our 2 points. Now I'm going to go back to menu. I'm going to go back to geometry. I want to draw the line now. So I'm going back to points and lines. This time I'm going to draw the line. Now a line is determined by 2 points. So I'm going to click on the first point we plotted and the second point we plotted. It has now drawn the line. Notice again, upper left-hand corner, I am stuck in drawing lines until I escape out of that. So now I have the 2 points and the line that were given to us in our document. We have one more thing that we can do here. Go to menu, go back to geometry. Notice down here it says measurement. On 3 is measurement. And one of the things it can measure is slope. So if you now point at the line, it's telling us what the slope is, and we click enter. I'm going to click enter again. You might have to hit it twice to make it drop. Again, all I can do is compute slope as long as that symbol's there, so I'm going to hit escape. The slope here is negative 0.8. So that's really negative 8/10. And negative 8/10 does reduce to negative 4/5. Now we've found it. Awesome. Now I do just want to give you, just in case you plotted the wrong point, so it wasn't supposed to be 0.3, it was supposed to be 0.4. If you double click the point, you can change the number to whatever you want it to be. And then the line moves and the slope changes. So if you accidentally click the wrong point, it's not a big deal. Okay. Also, while we're here, just like we did with the points, if I point at the line, notice it's saying line now, and I'm going to control menu, coordinates and equations. Look at this. It tells me the equation of the line, which might come in handy in the next 2 examples that we do down the road. So now you know how to put the grid on a graph paper, plot points, draw the line, find the coordinates of the points, find the equation of the line, and measure the slope of the line. All right, let's go back to our document. Okay, so what we did was we plotted the points using our geometry menu. Then we draw the line connecting those 2 points. And then we actually measure the slope. And all of this is found under the geometry menu. So go to menu, then geometry. You're going to plot your points. You're going to draw the line connecting those 2 points. And then you're going to measure the slope. Okay? All right. Next up, let's look at the equation of a line. So, probably the most common form that you guys know is the slope-intercept form of the equation of a line, where y equals mx plus b. M is your slope, and the b is your y-intercept. That's where the graph crosses the y-axis. So, we're going to take a look at this graph of a line that I have right here. We're going to find the y-intercept, we're going to find the slope, and then we'll write the equation of the line. So our y-intercept, that's where the graph crosses the y-axis, and I look right here, it crosses the y-axis at 4. That means that b is 4. Now we're going to find the slope, and you can do this by any of the 3 methods we had before. Remember, slope is the rise over run right, or your y2 minus y1 over, I'm going to use, you know what, I'm going to use this point right here. See that point right there where it hits the x-axis? That's the x-intercept. So I have a point there where we're at negative 2, 0, and then I have this point 0, 4. And if I look, I rise up 1, 2 points, and I run, oh no I don't. See, now I did do this on purpose, by the way, because what do you notice? I didn't go up 2, because notice I went from 0 to 4. That's not 2. That is actually a rise of 4. You have to watch out for the scale. So be careful, watch the scale. So every tick mark on the y-axis counts by 2. It also does the same thing on the x-axis. Now you also have to be careful because the scale does not have to be same on both axes. So when we rise up 2, we're actually going up 2, 4. And when we run right 1, we actually ran right 2. Now this is important also You must simplify your slope. You are not going to tell me that the slope is 4 over 2 because 4 divided by 2 is 2. So our slope is 2, which then means that the equation of our line y equals mx plus b is y equals our slope is 2 times x plus our y-intercept is 4. And there we go. Now I bet if I asked you guys, 99% of you, if not 100% of you, would tell me that your favorite form of the equation of a line is that slope-intercept form of the line. Guess what? I am here to tell you that your new favorite form of the equation of a line is the point-slope form of the equation. This is going to be your new favorite form. Now, you may not believe me, and every year I have kids that say, no way, I love my y equals mx plus b, but you know what? Before the end of the year, I have converted them. This will be your new favorite form of the equation of a line, especially for this year, and if you're planning to take AP Calculus next year, you're going to love this form. This is the form you want to use. Remember, m is still your slope, and it passes through the point x1, y1. So it's a point slope because we know a point and we know the slope. For instance, here's an example. We're going to write the equation of a line that has a slope of 3/7, so we know that our slope is 3 over 7, and it passes through the point -6, -1. So we know our x value and we know our y value. So if we have y minus y1 equals m times x minus x1, it's y minus our y value is -1. So when we minus a -1, it becomes +1. Please don't leave it y minus a -1. Equals our slope is 3/7 times x minus, and when we minus a -6, that becomes +6. This is the answer. You stop right here. This is perfect, because if you go through and you distribute the 3/7 and then you subtract the 1, if you're going to make a mistake, it's going to be with the arithmetic with those fractions. Don't give yourself the chance to make the mistake. Just don't do it. Just stop right here. When the equation is in this form, I can see the slope and I can see the point. It's -6, it's -1, and it makes it really easy to graph. We are done with that equation of a line. Okay, we mentioned these terms before. The x-intercept of a line, that's where the function intersects the x-axis. But not only that, anywhere on the x-axis, the y value is 0. And when you're looking at a y-intercept of a line, that's where the function or the line intersects the y-axis, which means that the x value is 0. Okay, and that's going to be important, because now what I want to do is I want to find the x and y intercepts for each of these lines, and then I'm going to graph the line. I am not going to put, notice it's not in y equals mx plus b form. It's not even in point slope form. It's in what we call the general form. Don't worry about that right now. It just means it's a constant times x plus or minus a constant times y equals another number, a constant. We're not going to do the algebra where we solve and put it in y equals mx plus b form. We're going to try to graph it without doing that. Now, because it's a video and you can't see my hands covering things, I'm actually going to write a few things out just so you can see what I'm doing, okay? But you don't really have to write everything. You're just going to tell me the x-intercept and the y-intercept. Now, an x-intercept, that's the value of x when y is 0. So this all goes away. And all I have is 4x equals 6. If I was to solve that for x, we would divide both sides by 4, and x would be 6/4, which reduces to 3/2. There you go. Your x-intercept is 3/2. And I'm okay if you write 3/2 or if you use the 1.5, because a lot of times when you're graphing, it's easier to use the decimal. That's okay. All right. Now I'm going to erase that part that I scribbled out. Now let's find our y-intercept. So our y-intercept is the value of y when x is 0. So all of that piece goes away. So again, you don't have to write this down. You can do this in your head, but I'm writing just so you can see it. Negative 3y equals 6. Well, negative 3 times what is 6? And most of you already know that answer, so you already know your y-intercept. If you divide both sides by negative 3, y is negative 2. So your y-intercept is negative 2. Well, now how does that help us graph? Well, let's see. If our x-intercept is 1.5, because that's where it crosses the x-axis, I'm going to put a dot there. If my y-intercept is negative 2, and that's where it crosses the y-axis, I put a dot there. And then I get my handy-dandy line feature. You guys hopefully have a straight edge. And I connect my dots. Don't forget to put arrows on the end, right? Please don't make me take off points because you don't put arrows on your graphs. Please make sure you put the arrows on your graphs. And there we go. We have the graph. So much easier, right? So now we have 2x minus 4y equals 8. And again, we want to find the x and the y-intercepts. So the x-intercept is the value of x when y is 0. So if we let y be 0, our equation is just 2x equals y. Divide both sides by 2. Our x-intercept is 4. So we're going to put a dot at the point 4, 0. Now our y-intercept, that's the value of y when x is 0. So if we let x be 0, our equation becomes negative 4y equals 8. Divide both sides by negative 4, and our y-intercept is negative 2. So we plot the point 0, negative 2. Now we get our handy-dandy straight edge, and we connect the dots with a line using a straight edge. Don't forget to put arrows on the ends. And now we have the graph of a line. However, there's a few things I want to show you on the calculator. Now, before we do that, the first thing you need to know is how to get it into the calculator. I know you guys know how to do the algebra to solve for y equals and put it in y equals mx plus b form. Let's try to do it without that. We know we're going to have f1 of x in our calculator. When you have x and y on the same side, what I want you to do, first thing is you're going to open your fraction template, and we're going to do this on a calculator in a minute. You're going to start in the numerator with what's already on the right-hand side of the equation. Now, if you were going to solve for y, you would have to move the 2x to the other side. How would you do that? You would subtract 2x. Then you would have to get rid of the negative 4, and you would divide by negative 4. This is what we're going to type into our calculator. Let's go. So here we are on our graph page. We're going to press Control Division to open our fraction template. We're going to insert our function 8 minus 2x over negative 4 and press enter. And here is our line, okay? Just like the one we graphed on paper. Now there's a few things I want to show you here. I know you all know how to Control T and look at the table. In the past, I also know that you've used this to find your y-intercept when the value of x is 0. You just scroll through the table, and you could find your x-intercept by scrolling and finding where the y is 0 and find the matching x. I am going to caution you. Welcome to 4R. This is no longer a New York State Regents class. No longer do we have nice, neat numbers all the time. This problem is nice, neat, and simple because this is a review from Algebra 1 and Algebra 2. Most times in this course, you will not find your answers in a table that is set up like this. So you need to learn some other possibilities and some other methods. Okay? I know you all have that habit of using the table for everything. It is a habit I need you to break. Now, another way we can find the x and the y-intercept. The x-intercept you can find if we tab back up and graph the line y equals 0. If you find the intersection of these two lines, and I don't care for this, whether you go to Menu, Analyze Graph to find the intersection, or if you use the geometry method, because there's only one point of intersection. We now know that our x-intercept is 4. Nice and easy. The reason we put in f2 of x equals 0 is because if you just use, here I'm going to Control Z and undo. So I no longer have that. Okay, and this time let's do the geometry menu. It doesn't matter whether it's analyze graph or geometry, but this way I've done both with you. Points and lines, intersection, click on the graph, click on the x-axis. Notice the calculator gives us a point, but it does not tell us the coordinates. And that is why we put f2 of x equals 0, because if it's written as a function, it will give us the coordinates of the points. Now to review, once we know we have the point, we can point at it. See how the finger's pointing and it says point. If I control menu, then coordinates and equations, now I have the coordinates. So if you forget to do f2 of x equals 0, then you have to remember how to find that point. Okay, other things you can do. You can also, from that geometry menu, geometry, points and lines, and we can put a point on. Now click away from the x-axis, somewhere on the line away from the x-axis, and make sure it doesn't get stuck on the grid either. I'm going to move the point a little bit so that it doesn't float with me. Now I'm going to press and hold the center, and I can slide this point, and notice how the coordinates change. You can also, if you want the x-intercept, that's the value of x when y is 0, so double click the y value, change it to 0. Now I have my x-intercept. If I want my y-intercept, I can again double click the x coordinate, call it y, because the y-intercept is the value of y when x is 0, hit enter. Now I have my y-intercept here at -2. And again, this point moves freely. This point over here does not, because it was found as the intersection between those two lines. Another thing we can do is if we go to menu and we trace and we graph trace, it's usually going to start when x is 0. Notice I'm going to go a little bit to the left, and as I move back towards the right, look at that. It says y-intercept. If you hit enter, it's going to drop a point there. Notice if I keep going to the right, when I get to that x-axis, it's going to say 0, and I can hit enter to drop that point. Now, the only thing I can do is keep tracing as long as this symbol is in the upper left-hand corner. So we hit escape to get out of that. Now we have several ways that we just looked at that we can find the coordinates of both of these x and y intercepts and other features of the graph. Okay, we're almost there. One more thing to review. The equation of a vertical line is x equals a number. That's because anywhere, remember, a vertical line goes up and down. And anywhere along this line, the x value is the same. Not only that, it hits the x-axis at whatever that constant number that it's equal to, the x-intercept. Okay, so it's really x equals the x-intercept. Now a horizontal line, which goes this way, that equation is y equals a number. And again, it hits the y-axis at C, which in this case is the y-intercept. So in this next example, when I ask you to write the equations of the vertical and horizontal lines passing through the points 2, 3, we are going to, first thing I'm going to do is I'm going to plot the point 2, 3 right here. There's our point 2, 3. Now, let's see if I use my vertical line. The vertical line is x equals a number. Well, in this point, which number is the x value? X is 2. That means our vertical line has to be the equation x equals 2. So watch what happens when I draw this line. It hits the x-axis at 2. My line keeps wanting to go crooked at the end there. And now I've got the line x equals 2. Now, let's say we want to do the horizontal line. And if I give you a question on a test, a quiz, or homework that asks for the vertical and the horizontal line, you must label them, please. Please label which is which. Otherwise, I can't guess. Okay, you must label. Now, if I'm only asking for the vertical line, then you can just write x equals 2. But if I'm asking for both, you have to tell me which one is which, please, okay? So we know that the equation of a horizontal line is y equals a number. Well, in this point, our y is 3. So y equals 3 is our equation. So if we look, when we go through this point and go over horizontally, it hits the y-axis at 3. And the equation of our line is then y equals 3. And there we go. All right, guys, that's it for today. I'll see you in class. Have a good one. Bye.